We are live. Are we on live now?
Yes, sir. We are on live.
It's a great pleasure for all of us to have Bhushan, Dr. Saraswat, as a guest in our summer research training program of CSIR. When we started it about a couple of months before, within a week, we have 16,000 applications, which was far above our expectations. We were thinking, sir, about 400-500 people may apply. But when 16,000 people have applied, we have tried to accommodate most of them. So around 15,000 people have taken this summer research training program, which has one of the important features as Eminent Scientist lecture. And yours is about 40th lecture in series, sir, and we are about to finish. And afterwards, Mr. N.R. Narayan Murthy of Infosys will be giving the lecture. With that, we will be closing the program. And this particular summer research program is not just a series of lectures. It has a summer project which has to be submitted. And most of the students have submitted their projects. And it also has essay writing competition, and we also conducted elocution competition wherein several thousands of people have recorded their elocution competition with a 3-minute video and uploaded in our website. And the screening is going on correctly. And we also have a quiz competition. And in addition to that, one of the important is that our people have made videos will be showing instruments and their working or some special experiments. Request you to open of these videos, sir, and we have about 100 videos already prepared. And this particular program will be telecasted live in YouTube as well as Facebook and MS Teams. Our footfall is a few thousand people, and we are really lucky to have somebody like you sparing your valuable time to talk to a large number of BSc, MSc, and PhD students working in different fields. And I don't have to tell how important are the contributions of Dr. Saraswat to building India towards Atmanirbharata. He, along with our Bharat Ratna Dr. Abdul Kalam, has played a very important role in building a lot of large number of projects in DRDO. And with this, I thank Dr. Saraswat on behalf of all the SRTP students and all the students of the country, because our students represent each and every state and union territory of the country now. So with this, we thank you very much, sir, for sparing our valuable time, your valuable time to talk to our students. And I request Professor Aayog Dhawan to introduce the speaker.
नमस्कार सर, आप सभी का इस कार्यक्रम में स्वागत है। मैं आज बहुत गौरवान्वित महसूस कर रहा हूं कि आज हमारे बीच न केवल आत्मनिर्भरता और आत्मविश्वास के एक एपिटोम, बल्कि जो हमारे मिसाइल प्रोग्राम के जिन्होंने संरचना करी वो हमारे बीच में है। टुडे वी हैव ए वेरी एमिनेंट साइंटिस्ट अमंगस्ट अस, Dr. V.K. Saraswat. He is one of the most gifted scientists of this country, and not only that, he is an accomplished researcher with more than 4 decades of experience, not only in research but also innovation and technology, and he has been a visionary in terms of the defense program. He completed his engineering from Gwalior, he did his master's from ISC Bangalore, and then a PhD from Osmania University. And during his illustrious career, he from scientist to scientific advisor to defense minister, director to director general of DRDO, and then secretary to the Department of Defense and R&D. Dr. Saraswat has been credited with development of liquid propulsion rocket engines and missiles, namely Prithvi, Dhanush, Prahar indigenously. He is the principal architect of the ballistic missile defense program, which included major technology breakthroughs. Dr. Saraswat also brought new dimensions to the strategic defense scenario through successful test firing of Agni 5 and Shaurya, and the initial operation clearance for light combat aircraft Tejas and induction of INS Arihant. He has also been a pioneer in shaping up the IIT Madras Innovation Center called MILT and Center for Training Needs for Armed Forces, the CRT for reporting, auditing and handling emergency response of information security incidents and so forth. Till recently, he was the DAE Homi Bhabha chair and initiated development of technologies for energy security, namely biomass, solid waste management, fuel cells, concentrated solar power, multi-junction photovoltaic cells, and so forth. And he has also been an architect for bringing up several institutions, in addition to bringing new dimension to aerospace manufacturing. He's been a recipient of several national and international awards. To name a few, he has been a Vikram Sarabhai Memorial Awardee of the Indian Science Congress in 2011. And in 1998, he was awarded the Padam Shri, and then 2013, he was awarded the Padam Bhushan. He also has been bestowed with the fellowships of several academies, both from India and abroad, including the International Academy of Engineering from Russia. He has also been bestowed upon him the honorary Corsa degree from 18 universities. And as you would have now known that he is one person who has taken not only technology, but also science to the hilt for the benefit of the common man. I think what his aim has been, and I've been very fortunate to have been with him in a few meetings, and I find in him the zeal, the zest, the passion, the desire to ensure that our country leads from the front, not only now, but in the future. And that is what he's trying to now build an entire ecosystem that can recharge and rekindle the fire and desire of science and technology in the budding scientists. He has also been very helpful to CSIR in ensuring that CSIR is catapulted to newer heights. He is currently the member of NITI Aayog and shoulders many honorary positions in the government and academic institutions. I think not only me, I think all the young scientists and students and mentors who are listening to him today will be blessed by his visionary leadership and what he has to say on science and technology for sustainable future. I have the pleasure and privilege once again to present before you the one and only Dr. Vijay Kumar Saraswat. So the floor is yours now. Thank you very much indeed.
Thank you very much. Sir, before we request you to give a lecture, Dr. Swapnali Hazarika will coordinate releasing a few videos through in your hands. So Dr. Swapnali.
Yes, sir. Yes, sir. Thank you, sir. Good afternoon, one and all. On behalf of Director CSIR NIST and CSIR SRTP 2020 team, we the organizing committee have prepared more than 100 videos which covers up all the instrumental facilities available at CSIR NIST Jorhat. It is our immense pleasure to prevail the learning techniques of different experimental demonstration throughout their working principle for every individual stuck at home in the current pandemic situation. Till date, sir, we have released a total number of 30 videos, and we have also received large number of viewers and supporters with a large number of valuable and encouraging comments. So, sir, on behalf of you, and with due permission from you, now we would like to release next set of 5 videos for public. Sir, these videos are demonstration on lab scale fabrication of supercapacitor, laser cutting machine, gas chromatography mass spectrometry, CNC lathe, mixed turn glass, and CNC 15 plus. Sir, should I proceed?
Yeah, please go ahead.
थोड़ा.
Thank you very much, sir. These videos will be available. Now, may I request our Dr. Saraswat to speak.
Thank you and congratulations for such nice videos that will be extremely useful, I'm sure. So I start my presentation on science and technology for sustainable society. I'll share my presentation on the screen. So just confirm that you are able to see my screen or not. I hope you are able to see my screen now.
So the PowerPoint has not come up yet, sir.
Yeah, but the title slide is visible. Science and technology.
No, sir, not yet, sir.
Okay. So,
It's visible now, sir. We can see it.
now you can see that, yeah. We have to redo it. Yeah. So science and technology for society, which is sustainable, what we are talking today. And I'm very happy that I have a large number of students and some faculties who have been actively involved in the research and development and translation of the research and development for the benefit of the society. Basically, I would like to start with the fact that basic science is what we practice, which is a basic tool for society's problem solving, which has been one of the major focus of the science for the centuries. The motivations to carry out research in science and technologies are multifarious, and we talk of advance the human understanding of the universe and all it contains, and also to improve the lives, health, and the freedom of all people. That is what we are looking at. And the first part of the motivation is basic research, and the second part is applied research. And the most used word these days is inspired basic research, when these two combine together. Basically, what we say that the science has to be linked with the majority of our societal needs, and all our policies with respect to investment, utilization of available resources, and sustainable development, they all form part of the triad and become the foundation for transforming our nation into a knowledge-based society. So actually today, if you look at the society of India as a whole, we have improved from an agrarian society to an industrial society to a knowledge-based society, to the intervention of the science over the last so many decades. Particularly after independence, we have made tremendous progress in a variety of disciplines of science, which has been beneficial for society. You have seen our space programs, which has benefited the space journey, our defense programs, which have resulted into capability in the defense area. We have seen our programs in the nuclear energy, in science and technology, which have made our country self-sufficient in this technology and having our own nuclear plants. Agriculture, first revolution, white milk revolution, all of them are products of the scientific development that took place in the last 70, 80 years. Now, how did that happen? Basically, because we had a science and technology as a perspective, and science perspective, technology perspective, and combined with the ecological, economic, and political perspective. All these three perspectives, when they are put together, you tend to get what is called the science technology society. And these three put together are used for taking the decisions today. And then these decisions lead to actions. And these actions, what have resulted into the growth of variety of products in the country in variety of the fields, as I mentioned to you, from agriculture to space to pharmaceuticals to IT technology to communication, and many areas which have resulted in overall growth of the society. So that is how science and society has benefited. The science is the principal driver of change. What you saw maybe in 70 years back, maybe 10 years back also, and what is happening today, you are seeing, as if, for example, there has been a tremendous social change due to internet, what has happened. And we are also seeing the biotechnology making tremendous change as far as the health and medical systems are concerned. You are seeing the defense technologies which have happened, the nuclear weapons, the missiles, the submarines and all that, and including weapons of mass destruction, which are responsible for the national security change. And environment also makes a lot of difference in this area. So you have climate change which is taking place. So science has the power to completely transform civilizations. For some, science has made life comfortable and secure. For others, it has meant death and destruction. It's a way we use science, it makes difference on that. So this is what I would say. Now, if you look at science as a means for sustainability, then you have to make sure that we understand what is sustainability. Actually, it's utilization and development of natural resources in a ways which are compatible with the maintenance of these resources, and we conserve them in such a manner that they are available for the future generations. And there are three pillars of sustainability. All of us know them: environmental pillar, the social pillar, the economic pillar. The environmental pillar is basically to maintain the natural resources and pollution prevention and biodiversity. Social is basically to improve the standard of living, education, jobs, and equal opportunities for all. And economic growth brings profit, cost savings, and research and development. So all of them are very, very important if you want to have a sustainable society. And we are seeing a growing scenario where you have increasing demand for resources and ecosystem services. But we also see on the similar point the declining resources and ecosystem services. So that is a short case where you get unsustainability. So what would happen if we have to get sustainability? We have to reduce consumption, and we have to make sure that the demand is reduced to a certain extent, and we have proper utilization of the resources to get what is called the sustainable society, which will meet the needs of the tomorrow's generation. So that is what we are looking for. There are actually four basic principles for what we call it the backcasting from sustainability principles. We can use backcasting for sustainability principles as an effective way to handle our complex challenges what we face today. And this is called ABCD approach. A is the awareness about the vision what we have. A is the baseline analysis we will can do. And from this baseline awareness and baseline analysis, we create solutions. And that is where the creativity comes. You see on the slide the present situation. You leap from one to the other to ultimately reach what you need. And then you get a future and decide priorities based on that. So from future, you backstake and see what the present should do to make sure that with the baseline analysis, you are able to meet the future demands. So that is where this principle of backstaking that. Now, there are 6 necessary and desirable transformations for sustainability. One is, of course, the energy revolution. What we have to see that facilitating a global energy transformation. What does it mean? It means that more than 80% reduction in the CO2 emissions by 2050. And having signed the COP15 agreement, we have a responsibility on us to reduce the CO2 emissions by about 2030. Same thing is happening about future food, a food system transformation to achieve plus 70% production by 2050 through sustainable intensification. Today we have a situation, we do food production with flood irrigation and we do a lot of pesticides and fertilizers which are actually not very good for the health of the soil and also basic ecosystem. So we have to go for sustainable intensification of the food production methods. And we are seeing migration of people taking from villages to the urban areas. We are becoming an urban planet. As I talk to you in 1 minute, almost about 30 people migrate to a city. So that is the kind of migration which is taking place. And more rural areas are getting converted into urban areas. So you have achieving sustainable urban living. That is our another transformation required. Then we have an increased population. We know that by about the next 2000 years, 2050, we'll have a population which will be close to 9 billion people. So we should learn how to adapt to the population transition and preparing for a world of 9 billion people. Then, of course, biodiversity and management transformation is very important. And the most important part is strengthen the global governance. That means equity part, that is inclusiveness. But in the governance, we should have a total inclusiveness picture as far as sustainability is concerned. Now, all this has to be supported by science and technology in a big way. That's why if you take science and technology and sustainability as the basic foundation for that, you will find that our process of manufacturing also has changed. Now we are not talking of just manufacturing. We are emphasizing on all 4 product life cycle stages. We are looking at the pre-manufacturing stage, how the materials are extracted, how the materials are processed. We are also looking at how the manufacturing is done in a lean manner, in a sustainable manner. And we are also looking at the utilization and how the utilization is done properly or improperly. That means the demand base and post-use, when the equipment has lived its life, how to recover, retire, and then treatment and disposal. These are the 4 cycles which are becoming very important part of the entire system. So there's a closed loop material flow, as we call it today, in terms of material extraction, material processing, material manufacturing, use, retirement. But after retirement, also there is a journey to be performed. And that is a difference between the 3R concept and the 6R concept. After retirement, you look at, earlier we used to only worry about treatment and disposal, but actually we have one more cycle after use, recover, recycle, redesign, reduce, remanufacture, and reuse. So this is how it becomes a 6R cycle. And only after we have done number of these cycles of recover, reuse, and all that, we will go for disposal and treatment. And as a result, you will have minimum disposal and treatment requirement, and you will be saving the planet in a big way. So the manufacturing processes which have been there earlier, traditionally, which used to base upon substitution process, in which we used to cut metals, this, that, and all that, and they changed over to lean manufacturing, where we switched over to what is called lean manufacturing, in which the reduction in the waste was minimized. And we have later on the green manufacturing, in which we are reducing the pollution. And that is a 3R approach which I mentioned to you. But now we are going for 6R approach, what is called the sustainable manufacturing, in which the focus will be more on reduce, reuse, recycle, recover, redesign, remanufacture, and so on. So this is a typical sustainable manufacturing cycle which is getting evolved over the years. And we have a large number of stakeholders which will make looking investment in this line. And I'm sure the Industry 4.0 revolution, which is going to take place or is already on, will certainly be based upon these sustainability principles, wherein you will have minimization of the energy, green energy, you will have minimization of the waste, you will have reuse, recycle, all these things will come as a total system. And that's why the factories will be green factories, which will be lean, clean, and green in the future to come, where you will have remanufacturing and recycling, you should have management of the hazard, you should have total energy efficiency management, then product life cycle, which are to zero emissions, no waste, and the entire process of manufacturing will be sustainable process. And technical intelligence, that is where the Industry 4.0 will be coming. That will also help in reduction of the carbon footprint. So this is the nature which is of the new factories which is going to take place. Even engineering education, what we do engineering today will certainly get transformed. For example, today's engineering we considers the object, what it has to manufacture or design or develop. But sustainable manufacturing will look at, engineering will look at considering the system in which the object will be used, the entire system, the entire ecosystem. It will focus on technical issues, traditional engineering. But in the case of sustainable, we will integrate technical and non-technical issues also, which are related to ecology and things like that. And the traditional engineering will generally focus on what is called the immediate problem solving, somehow solve the problem. But we in the sustainable portion will strive to solve the problem for indefinite future. And today we work only in the local context, but in sustainable we work in the global context. The planet as a whole will consider. And assume that I will deal with only technical problems with politics, ethics, and social issues. They will be dashed by others, but no. In sustainability, you will have to ensure that the need for engineers to interact with experts in other disciplines related to the problems. So that is a change in the engineering which is taking place in as part of the sustainable transformation. Even today, I have noticed a large number of students are happy with the evolution of the computer system and simulation techniques and all that. That people tend to remain with the up to simulation, as if they have done the simulation on the computer, the goal has been achieved. No, we have to teach students how to formulate the requirements and objectives. We have to develop both creative and critical thinking skills and abilities. Reinforce the concept that if you can't build it, you cannot use it or sell it. You have to make it hardware. And introduce and develop project management skills and awareness of the cost and budgets. Demonstrate the importance of communication skills. If you can't explain your solution to someone else, you haven't solved the problem at all. We have to demonstrate the value of teamwork. The two more diverse heads are often better than one. So this is a kind of change designed to build and take up a sustainable situation. Even the curriculum for higher ed will involve sustainable development as an integral part of it. For example, a curriculum will have focus on research, public awareness, legislation, on mission planning, purchasing, operations, on student life, and also community outreach and partnerships and professional development. All of them should form part of the curriculum if we had to make a wholesome student tomorrow who will be able to perform the functions of transforming the society from today's society to a sustainable society. And for that, the students and to possess very good skills, and those are called adaptive leaders. They should be strong in analytical skills. They should exhibit practical ingenuity, possess creativity. They should have excellent communication skills with multiple stakeholders, and they should be good in business and management skills and leadership abilities. And they should maintain high ethical standards and strong sense of professionalism. They should be dynamic, agile, resilient, and the society is evolving. And if we don't learn along, we will remain behind and we will not be able to contribute with respect to the demands of the time. So it is absolutely essential that we have to be a lifelong learner. And ability to solve problems, putting them in a socio-technical framework and an operational context. These are some of the attributes which the engineer of today needs. We are amidst an avalanche of new technologies, as many of these reports are indicating today. And you see the traditional R&D which used to be there, and what will happen to tomorrow's R&D. We have new items like biosensors. We have new techniques for machine learning, 3D printing, artificial intelligence, e-sourcing and e-procurement. We have seen in the pandemic how much e-procurement and e-sourcing has been of great importance. The trend is go for synthetic biology. That means we are trying to reach biological means by which we will be synthesizing closer to the nature. Then we have advanced process control, data architectures and blockchain, data management, data analysis, data mining, and shared databases, virtual, augmented, and mixed realities, simulated chemistries. These are the new challenges which are coming. So traditional skills will get transformation from ideation to organization to connectivity to process to analytics. And these are the new R&D capabilities which have to be inbuilt to make a R&D for future tomorrow. So even for sustainability, we need these changes because these are the R&D evolution pathways which will make our society sustainable tomorrow. All the changes we conduct research, operations, maintenance. How do we prepare and what must be our focus? Have to have a relook with respect to the changing technologies. And these disruptive technologies that are transforming the future, they are going to make a major indent. You have already seen mobile internet, how much it has made mobile computing devices and internet connectivity, and the society has completely got transformed due to internet. And further transformation will take place with the advent of artificial intelligence going on that. You will see autonomous and automation of knowledge work, which will ensure intelligent software system that can perform knowledge work tasks involving unstructured commands and subtle judgments. Internet of Things is going to happen, is happening already. We have networks. The fact that we are talking on a web conference, this itself shows that how much progress we have made today, that physical distances have been only on the RF and wireless. Cloud technology, which is actually making the computer hardware and software resources delivered over a network of the internet. Advanced robotics, which will build driverless cars and things like that, which will bring high level of automation. Autonomous and near autonomous vehicles, these are going to happen. Next generation genomics will ensure fast, low cost gene sequencing, advanced big data analytics, and synthetic biology. You should be able to write the DNA. Energy storage. Already we are seeing the solar energy and battery revolution that is taking place. Manufacturing is seeing a major advantage in additive manufacturing and 3D printing, which will ensure that subject manufacturing is going to give way for minimization of wastage of materials, and you can have complex shapes and sizes that can be done in a very cheaper manner and a faster method. New materials are emerging, which will bring low weight, new wastage, and new strength. Advance of oil and gas exploration recovery, which will make sure that we have recovery techniques that make extraction of unconventional oil and gas economical. And of course, renewable energy is making all the difference as far as the energy is concerned. The economic impact of all these disruptive technologies have been analyzed by us, and you will find that achieve about 500 to 1,000 billion annual economic impact, which is 20 to 30% of the India's incremental GDP from 2015 to 25. It will provide 400 million additional people with access to qualified healthcare. Have 300 million financially included people. These disruptive technologies will bring that change. It will provide about 14 to 24 million workers more years of education. We can achieve 15 to 60% yield improvement. We can have through precision agriculture. We can save about 50 to 95 billion from energy technologies and gain about 17 to 25 billion from intelligent transportation. Create jobs for 10 million tech-enabled workers in healthcare, education, agriculture, citizen services, and financial services. That is what would happen. And estimated potential is shown in this slide. You can see it is running into trillions of dollars. Mobile internet being the highest, and the lowest being the renewable energy. You can see all of them have got low probability and high probability indicated on dark blue and the gray color. You will find that you are likely to achieve such a tremendous economic growth because of these technologies which are emerging as disruptive. And these will happen not in very distant future. They may happen in next 5 to 10 years, 2025. But we have to solve for sustainability some very complex problems. As I mentioned to you at the time, we have to solve the problem of transformation. So we have to solve the problem of population growth. We have to solve the problem of transportation, which is happening. Road space is becoming less and less. Transportation requirements are becoming more. So new concepts of shared mobility, autonomous cars, and many things are happening. We have cities which are becoming urbanized, and so we are looking for smart cities. We have energy solutions because the energy demand is increasing. We have pollution to control, so clean coal technologies, solar energy technologies, wind energy technologies, hydrogen technologies, all of them will be the solution for energy. And environment control is a major requirement, because if we don't control the biodiversity, if we don't reduce the CO2 emissions, if we allow the temperature to rise beyond what is happening today, and don't keep it below 2 degrees centigrade as a limit identified by the United Nations, then we are likely to run into global warming problems, which will have the existence of the planet itself will be a problem. And we have serious problems which are emerging today due to the kind of pandemics which we have seen. Not pandemic, of course, this time we have seen in the form of COVID-19. But if you see the last 20 years, we have had large number of these viruses, Ebola, Zika, SARS, and all kinds of things that have plagued the society. So health becomes our major focus as far as the human safety is concerned. So we need to look at all of them. These are social issues requiring complex solutions. And science and technology is the answer for doing this, bringing together environmental science and development science through research and nature-society interaction. That should be our approach. We should be concerned for enlarging scientific capacity in developing countries and providing scientific support for local action. Let us look at all of them. We have to make science which is integrative. That means natural science, social science sectors, human activities, scholars and practitioners, all of them have to integrate. We have seen this happen in the last 6 months. For meeting the goals of this pandemic, the rate at which India's S&T system has really worked to come out with solutions in a very short time, deliver ventilators, deliver PPE, deliver sensors, testing methods, diagnostic methods. I think we have the capability. That means if we integrate our science the way we have done in the last 6 months, we will be able to achieve the goal of sustainability in a big way. And science, of course, it is a fundamental scale, non-linear processes and complexity, the unity of nature and society. That is the way we have to look at it. Science that is regional and place-based. What is applicable in US may not be directly applicable in India. We have to choose and customize science for the ecosystem in which we are working. Where people and ecosystems are, where a transition can happen, where integration takes place, and where complexity is understandable. So this is a very important part which we have to look at. So you have science improving understanding of the threats and possibilities, enabling advancing technology. We have technology driving economic growth via new products and services, reducing resource use and environmental impacts. And S&T together integrate as assessment of options, advice to decision makers and public about costs, benefits, dangers, and uncertainties. S&T education towards more and more S&T literate society. So core research themes which are emerging today in science and technology for sustainability are modeling and dynamic interactions between nature and society. We have to model that. Changing long-term trends in the environment and development. We have to study them and put them as part of the model. We have to understand the vulnerability and the resilience of places, ecosystem, and the livelihoods together. What are the vulnerabilities? We have seen this in the thing. We are vulnerable through this Zika, through this COVID-19. How our society became resilient by taking certain act, and we could fight it. And tomorrow, I'm quite certain that we'll fight it in a big way, in spite of the fact that there is a possibility of re-emergence and re-mutate and so on. But I'm not, that's the kind of understanding. If we have the understanding of the vulnerability and resilience, then we can find solutions. Identify limits or thresholds for serious degradation. That's another thing which we have to do. Up to what limit we can degrade, and beyond that we'll fall back. And creation incentives to move society towards more sustainable trajectories. I think if we don't create these incentives, people will not move in that direction. And that is what has happened in the last 100 years. The technology kept on growing and providing comforts to people, but we did not realize the adverse impact of this technology, which resulted into this kind of a situation what we have in terms of the pollution, in terms of urbanization, in terms of the lack of resources, in terms of so many things, diseases, health, and so on. Now, people should be incentivized, the society should be incentivized, the system should be incentivized to move towards sustainable trajectories. And of course, providing usable knowledge to navigate a transition towards sustainability. Knowledge is very important. Indian system today, let us talk about Indian system. Are we ready? Are we in a position to translate ourselves to this kind of a sustainable system? We have third largest technical manpower. Today, India ranks 8th in the world in terms of number of students graduating. India is to third spot in the number of science and engineering publications, and science and technology powerhouse and promoting both public and private sector involvement in the R&D. Union budget in the largest ever allocation is 6,302 crores to the Ministry of Science and Technologies, and biotechnology and CSIR also had their own contribution. With more and more multinational companies setting up their R&D centers in India, the sector has been an uptrend in investment in recent years. We have a large consumer-based demand for cheap and durable products that could meet local requirements. It will drive the need for innovation. We have R&D investment was forecast to reach about 94 billion in 2019 and estimated about 86.24 billion in 2018. R&D investment helped India companies to overcome tight competition with affordable products. And we have the ecosystem, the science, technology, and innovation system. We have R&D bodies, we have academic sector, we have social conduct ministries, we have industrial R&D systems like CSIR, we have R&D by multinational companies, and we have R&D and new groups. So we have a variety of things. And we have a thriving private and public sector in industrial sector like TVS Motor, Bosch, Tata, Mahindra, innovators in the automobile industry. India being ahead of China, South Korea, and Japan in generating huge opportunities for Indian automobile brands. So we have the growth in certain sectors. Certain sectors we are lacking. We have to make up for that. In certain recent areas, Government of India has implemented several fellowship schemes to nurture human capacity for advanced research in the country. We have declared 2010 to 2020 by the government as a decade of innovation. And as a result, we have come out with the science and technology policy in 2013, which is implemented today. And we are now working for the next policy along with the Department of Science and Technology. We have an Inspire program, fellowship program, and number of students enrolled in CSIR has increased by 22% in last 5 years. Indian R&D investment, as I mentioned earlier already, a series of new investments were recently announced by Cisco India to enhance cybersecurity. Cisco India has signed an MOU with the CERTIN to establish a threat intelligence sharing program. And we have a NITI program. Indian government plan to invest 29.75 million for getting up to about 100. So you can see how from 2014 to 19, R&D spending has changed to 94, which is a futuristic, but is not futuristic, it's a realistic now. By 2022, R&D expenditure is targeted at least 2% of the GDP. We have been working for it, doubtful whether it will happen, but this is the goal we have set for ourselves. As per Union budget, the government set up National R&D Research and Foundation for R&D. This is in the process, it will get set up. And the one great thing that has happened is India jumped to a 52nd place in the Global Innovation Index from 85, what it was about 4 years back, due to the proactive policies and implementation strategies which various departments have followed for promoting innovation in the country, including NITI Aayog's Atal Innovation Mission. So you have advantage for India, you have a robust demand, you have attractive opportunities in India today. I won't go into details of each one of them. We have new policies, PPP for promoting exchange of scientific knowledge and R&D. We have patent persecution highway program. We have rising private activity in R&D. We have establishment of center of excellences in variety of places, new millennium of Indian technology leadership on a PPP basis. We have increased investment of private players for setting up R&D centers. Particularly, I am finding this happening in the biotechnology area in a big way. I wish this happens in the engineering field also. This will certainly bring in a larger change as far as the Atmanirbhar Bharat is concerned. It will also bring a change in terms of contribution of manufacturing to the GDP from 15% to what we are looking for, 25% by about 2025. But there are challenges. All this is very rosy picture. We also have challenges. Major challenges in the Indian R&D ecosystem is, even today our expenditure on R&D is low. We have some suboptimal research infrastructure in many areas. And we have still the private R&D is not adequate. We have depth of it. And there, while all attempts are being made to have a strong linkage between R&D, academia, and the national laboratories, but there are missing linkages even today. So the major underlying challenges which came out during the COVID-19, I would like to share with you, because this is the last 6 months exercise NITI Aayog did. We found that we are highly import dependent, and nature of Indian industries is like that. The presence of stringent regulatory mechanisms for introduction of novel drugs, vaccines, and equipment. I think our regulatory process needs to be relooked because it is very cumbersome and it requires tremendous, it has got its own bureaucratic involvement in a big way. We need to streamline this and make sure that it rises to the occasion when the emergencies occur. So there has to be what is called a fast track approach, there has to be a medium track approach, and there has to be a normal approach. So we need to evolve a new system of regulation mechanism. Inability of our scientific institutions to deliver solutions. See, we had large number of institutions who were technologists. They were able to say, but they had not gone beyond proof of concept or technology maturity level 3 or 4. Technology maturity level 3 or 4 or POC does not enable commercialization. You all agree with me. So we have to change our tactics of R&D in such a manner that when we develop technologies, they go beyond 3 and 4 and we are ready for commercialization. We may not commercialize, but at least we should have done a pilot program which will ensure that scaling up would be a possibility if a commercial entity comes in the force. And many times we have non-availability of firm orders and line of credit from banks to meet the capital requirement for operations and handicap. For this, we need a strong policy framework to promote India as an R&D hub. And policy support is needed for strengthening capacity in basic research, strengthening institutional capacity of the research, and which are emerging today, to take it forward in a manner in which we will have competitive advantage. Otherwise, if we use only the old technologies, you will miss out on the competitive advantage, for which R&D is a must. We should also identify what are the priority areas. We should not try to do everything all the time. So agriculture and food, medicines, health and healthcare, water, energy, infrastructure development like road transportation, manufacturing, defense and law and order, environment, ecology like garbage recycling and waste disposal, waste to energy and waste to wealth and so on. We have to really make a tremendous progress in computers, information processing, data storage and processing. We should be self-sufficient in making supercomputers in our country. That's what we are pushing now, high performance computing system program under my leadership today. And NITI is supporting us in a big way. We'll have our own supercomputers this year, fielded for various institutions. Similarly, education. The new education policy, I think, is the right choice at the moment, because it will bring in a drastic change from our present system of education to a creative and skill development kind of an approach, which will bring creativity. And we will graduate we will not be only producing students who seek employment, but we will be creating students who will be providing employment. So that is a kind of education policy which is emerging today. For this, the youth has to play a major role. And since a large number of students are listening to this my talk, I thought I should talk to them. There's a youth power which is responsible for this transformation. Mainly because we have second largest population in the world. More than 50% of the population is below the age of 25 and more than 65% below the age of 35. So you have what is called the demographic dividend. And this dividend is not going to last too long. You will also age. So 2040 or 2045 is all that you have. So you have another 15, 20 years to take the advantage in this area. UN's World Population Aging Report estimates that by 2040, India will remain one of the youngest countries in the world. In order to benefit from young people's capabilities, communities must ensure opportunities for youth to be engaged in development processes. This is a major thing. We do not involve our young people. And so the communities have to make use of the dynamism, their energy, their innovativeness in a big way. If youth are unemployed and excluded, they can be a source of social disruption. Hence, there's a need to create an enabling environment for youth participation. And for that, we have to provide diverse opportunities for young people to engage with caring adults and outside their families, to promote positive relationships with other youth, to provide opportunities to learn healthy and valued behaviors, to develop senses of security and personal identity, be happy and healthy, move into healthy and productive adulthood. But there are challenges to young Indians. They have to answer 4 major questions. Many of the young Indians do not know what is my passion, what is their passion and strength. Unless you have passion and strength, you will not be able to have your development in the right direction. Will I sustain and build a career accordingly? I should build my career based upon my passion and strength. Where is my career going? Have you ever analyzed? Are you willing to work hard and long, but the workplace must be fun? In addition, there are issues like employment and employability, gaps in education, skill and vocational training, and one of the largest of our country faces is the no longer enough for organizations to provide on-the-job training. We should have capability to survive in dynamic and competitive Indian market. To overcome these challenges, there is a new doctrine which is coming, positive youth development theory, which is both on vision and ideology for engaging with youth development. Its attributes can be organized in 5 C's. One is competence, another one is connection, caring, confidence, and character. If we can build these 5 C's, then the 6th C, which is important, is the contribution, will automatically get realized. So we have to build these 5 C's. And youth have to play the following roles: community level change agents, enhancing the governance by participation, and working as a pressure group demanding citizens' rights, community level initiative by monitoring systems like health, education, public distribution, advocacy by putting up demands before the stakeholders, and most important thing, entrepreneurship, startups. It's a good thing that India has really made a tremendous progress in the startup culture today, but that startup is getting limited to only service sector. I want that startup to come in the engineering sector. Then only the wealth will be created. So it is important for us to do this transformation today. And there are skills that have to be provided for this youth to contribute for sustainable development: critical thinking, creativity, collaboration, cross-cultural understanding, communication, computing, and career and learning self-reliance. These are the 7 C's that have to be imbibed in the students which come out from the various institutions today, and they will have tremendous impact. So these are the skills which needs to be embedded when the students are getting trained in various institutions. And if you have all this, then you will be able to create what is called leadership for sustainability. Holistic principles of leadership for sustainability are, it is a system which empowers themselves to take responsibility. People think that I have not been given responsibility. No. In the sustainable system, a leader, it empowers himself to take the responsibility. Look for holistic interactions. He will be looking for not just for mundane things, holistic interactions. Convert authentic conversation into useful conversation. Understand the creative tensions which holds potential for breakthrough thinking. See, tensions will always be there. Like pandemic is a tension, but through SMT, through breakthrough thinking, we are able to find great solutions and we are able to tide over the problem. So this is called leadership quality. Recognize that outcomes unfold in complex dynamics. If the simple system will not give a major outcome, a complex dynamic system will give you very tremendous outcomes, which will have a far-reaching impact on the society. Notice and attend to human dynamics of transformative change. This is how the humans will play. It's a very important part. And experiment, reflect, learn, adjust, and share. These are the steps which you have to do when you are in a sustainable leadership role. And most important thing is ground themselves in personal integrity. This is something which has to be done because, as Dr. Kalam used to say, what a basic bane of the Indian society, why Indian alone, global society, is the lack of personal integrity among the people today. And if we want sustainability to really be available in a society, I think we have to ground ourselves in the personal integrity in a big way. So then you will have sustainable leadership. So to be transformative, there are certain suggestions I want to give to the students. Provide equal opportunity to equal merit and enhance worth of your colleagues. Service to society is more important as compared to your personal achievements. Every work is important and thus do not trivialize details. Be strong in your knowledge, but be humble in learning from colleagues. Occupy a position below your capacity and capability. This is very important. I will always advise, occupy a position below your capacity and capability. This shall bring appreciation and more satisfaction as compared to occupying a level higher than your merit and capacity. It will lead to dissatisfaction if you really do what is called a very just introspection. Then you will find that you are at the wrong place. Generosity is a virtue and practice it in a liberal measure. Envy is a poison, avoid it at all costs. Aim to be number one in everything, have an Olympian sports spirit of competing, and discipline, good health, competence, and character are your best assets. So I'd like to give key messages. The world needs a rapid global transformation to a new development paradigm, human prosperity within a safe operating space on the earth. This new Anthropocene logic places sustainability at the forefront of all developments. The challenge, global revolutions in food, energy, new approaches to urban development, transport, circular economy, development, global governance. These are some of the challenges which we have to overcome to get sustainable society. And SNT must and play a key role in delivering integrated system solutions for world prosperity within the Earth's SOS. And planetary challenge requires global networks of scientific collaboration. I want to share with you this very important slide, and that is, if you look at the world today, God had created what is called the biological world, which is shown in the left triangle, biological or the natural world, which has got various, in the hyperspace, it has got space, earth, ocean, as part of the ecosystem. It is self-organizing, it is a micro-macro relationship with internal communication among the living, all these people. But this world is growing slowly. On the right-hand side in the blue color, you see the artificial physical world which we have created. The hyper system consists of society, science, economy, and technology. We think that by doing all these four, we are in a position to make progress. and it self-organizes itself through science, technology, and economy, and with some kind of an international. And this world is growing at a very faster pace. But unfortunately, the biological world is living is outside the outer cover of the physical world. And as a result, when the physical world is growing, it is causing tremendous strain on the biological world. And that is what we are seeing in the form of sustainability issue. And that strain is actually breaking or really bringing tensions in the biological world. This is called ecological dilemma and of Luttman's ecological dilemma. And if you want to remove this strain on the biological world, the only answer is sustainability. And sustainability requires a language. And that language is, who is the man, who is the person who can bring this communication between the physical world and the biological world. This is the self-consciousness and consciousness of nature in the man. The person should have, the people in the world should have the self-consciousness and consciousness of nature, and that is the world of the spirit. That's what you should have. I won't go into beyond, because beyond that, if I go, I'll end up into the domain of spirituality, because self-consciousness comes to the spiritual perspective and following the ethnic value system. That's sometime later. It is important for us now that we instigate the change in order to improve living standards of all and reduce the impact on the planet. Choices that we make now will shape our opportunities in future. Alternative models and vision for sustainable future is not enough. Key driver is to change this transformation. And education for sustainable development is important. Education as a delivery mechanism to a lifelong, holistic and inclusive learning process is required. This ESG, the handprint is the measure of the ESG action. Action that is directed to decrease the human footprint. We are having a human footprint on the planet Earth today, and that makes make the world more sustainable. The handprint will make the world more sustainable, and footprint has to be reduced. Handprint is a new tool being developed by the Center for Environment Education. One needs to ask what one does at individual, community, and global level, analyze positive impact of the three aspects of sustainability, environment, society, and economy. Any decision you take, it you please analyze from the perspective of all the three pillars. And ask questions, and then only your social engagement and your awareness and investment should be driven. While footprint is a negative effect you leave on global resources, handprint is your positive efforts towards sustainability. So increase your handprint and decrease your footprint. Creating new knowledge towards solving social problems. Science and technology exploration and exploitation in harmony with the national priorities. Strategies to be evolved jointly by experts in the field, by social activists, by bureaucrats and public in the field of agriculture, food and all that. Which necessity of research processes and social scientists and society leaders to take lead for converging problems areas to work strategies and decisions. A strong and effective S&T base make India globally competitive and ensure the national security. Knowledge generated out of science and technology has a right impact on economic growth and social development, leading to improved living standards. We must search for the truth by using our creative thinking endlessly, but in application, we must respect to human life, free honor, family, cultures, and our goal should be health and welfare. A prince, philosopher, saint, and teacher mentioned the professionals in an excellent manner. With that high strengths, build your capacity and capability to make outstanding contributions in your chosen pursuits with ethics, sensitivity, and selectivity, and make the country proud with your achievements and achieve the goal of sustainability. That is all I would like to share with you today. Thank you very much. I'm open for questions.
Thank you very much, sir. बहुत बहुत धन्यवाद for your words of wisdom. And I request Dr. Shastri to take over and conduct the question answer.
Thank you very much, sir, for your excellent lecture. And before I can hand over to sir, is it possible for you to take a few questions, sir?
Yeah, no problem.
So before that,
I've lost
Dr. Kalai,
we are doing connection. Yeah, I can hear you. Please continue.
okay. So our students, Lisa Muni Kalita and Monty Gogoi, will take the question answer session, sir. Lisa and Monty, you are there?
Yes, sir.
Yeah, please.
Thank you, sir. On behalf of our director, CSR NIS, and the entire FRTP team, I would like to thank you, sir, for your insight.
Madam, you are not audible.
I think there are two connections. You need to switch off your one of the connections. That's creating an echo.
Okay, sir.
Yeah, try again.
Try. Use only one connection.
Yes, sir.
Now it is clear. Go ahead.
Thank you, sir. On behalf of our director, Dr. G. Narahari Sastry, sir, and the entire SRTP team, we would like to thank you, sir, for your such an insightful and informative lecture. We are glad to share that there are numerous appreciation comments as well as numerous questions in MS Team, YouTube, and Facebook, sir, and there are lots and lots of questions. So if you would permit, we would like to begin the question and answer session, sir. Should we?
Please go ahead. Please go ahead.
Thank you, sir. At first, I would like to say that Dr. V. Prakash, former director, CSRI, CFTRI, and Padma Shri, have appreciated your lecture and congratulated you on the issues that you have dealt with. He have asked few questions.
Thank you very much.
He have asked few questions. So the first question is, there is a huge gap between a breaking innovation in science and its reaching scalable level of applied and reaching the industry so that the product made in India reaches as fast as possible to the public. One needs to reduce this gap very much. And what is the opinion of how does one reduce this gap?
Yeah, I think our innovation ecosystem has made considerable progress, but there is still one area which is missing at the moment. If you look at a typical innovation cycle, innovation cycle passes through what is called valley of death. That means you have done understanding, ideation has taken place, you have sort of done some simulation and things like that, and you feel that there's a possibility. But then the moment you start doing hardware and you find that reliability, repeatability is not coming, you tend to get into valley of death. So at that point in time, there is a huge investment required because you have to make sure that you do number of iterations, you do scale up and things like that. Unfortunately, in our funding system for innovation today, this segment is missing. And while we are able to, what is called early stage innovation, we are able to support through the various academic institutions and also science and technology departments. The mid zone and later scale innovation, we are not able to support. And this should actually come partially from the private enterprises, angel investors, as well as the venture capitalists. And partly it should come from the government. Now, in both cases, we are finding that these two parties are not in a position to provide. So I have been recommending that India should create what is called Value of Death Fund. And value of that fund should be possible to take the innovation from TRL 4 or 5 to what you are talking of, commercialization, and scale up in a big way. If that happens, I'm sure this gap will get bridged. This is my answer to what is feasible and what should be done.
Thank you, sir. His next question is, innovation-driven process at a young age. Sorry, sir. Am I audible, sir?
Yeah, now better. Yeah.
Yes, sir. The next question is, innovation-driven projects at a young age of middle school to understand nature, like your slide of butterfly on TNS, a young boy or girl must raise this innovative question of how it can have so many colors, and he must be involved with this project for 2 days with a neighborhood science teacher or scientist who may be retired, and he or she will involve this child to explain the whole thing. That's when the innovation will spark in a young C.V. Raman or boss in the system. How does one promote this idea and practice at that young age?
The Government of India, again, NITI Aayog has started a program called Atal Innovation Mission. And under the Atal Innovation Mission scheme, we have created more than 3,000 innovation centers in primary schools, middle schools, higher secondary schools. And we have also created mentors, which are among the teachers, and we have also created the guides for the students to do the innovation. I am sure this ecosystem has fully developed now, and we have given them adequate resources, both in terms of computers, electronics gadgets, and also experimental facility. And time to time, we are also doing what is called interaction with them. And any innovation which is coming out from this particular system, we are taking it to a level so that it can also go in many times to a scale-up mode. So this Atal Innovation System should be made use of by those students in the primary school, middle school, who want to get a better better understanding of the innovation process and contribute to this innovation process. Because almost 3,000 centers across the country have been opened, and more are going to be opened. And those schools which are already capable of taking such a challenge, they are welcome to apply, and we will be in a position to support that. And in this, the retired teachers who are available can act as a mentor, so they can spend more time in clarifying the doubts of the students and guiding them towards the ultimate product through innovation.
Thank you, sir. The next question is, do you think our education system should focus on overall development of students with respect to all the necessary subjects rather than focusing on one?
In my presentation, I have said that we need a wholesome citizen. We need a wholesome citizen. We need to develop specializations and things like that at a much later stage in life. But by the time you come as a graduate, or by the time you become a postgraduate, you have to have a much wholesome approach towards development of the personality of a student. So that personality of the student development requires your focus on social, academic, human, all kinds of activities which are related to its personality development. And the most important thing is we have to imbibe in the student the capability for creative thinking. And creative thinking will come in all parts of the personality. It will come in the academics, it will come in the social, it will come in the sports, everything it will come. So the moment you bring in that creative thinking process and project-based learning, you will find that the personality development is overall. I advocate a wholesome personality development, and the education system should promote that rather than making him only specifically groomed in a particular discipline. Like we do in the case of medicine today, we make a general physician or a general surgeon or general, then we give them specializations and things like that. Same thing to happen in all fields. It should be like that. We should create a person who is good in vocal sciences. We should create in the skills. He should be good in communication. He should be good in solving problems. He should be good in doing some kind of entrepreneurship. So we have to create that kind of, and education should promote that.
Thank you, sir. Sir, can we ask you a few more questions?
Yeah, please go ahead.
Oh, thank you, sir. Sir, the next question is, according to you, which is that one area which requires immediate revolutionary changes with respect to sustainability?
Can you repeat?
Yes, sir. Sir, according to you, which is that one area which requires immediate revolutionary changes with respect to sustainability?
I think one of the major things which we have to focus on sustainable, what is called energy is one area where we should look at in a big way, and recycling, what is called circular economy. We have to look at circular economy as a major focus for sustainable development. And the moment you will go for circular economy, all parts will come, which will take care of the environment, it will take care of social, it will take care of the resources. So if you bring in circular economy, then you will have a sustainable development of the society.
Thank you, sir. The next question is, sir, how do we see the future of simulation and modeling activities in science and technology in India?
Oh, it is going to be actually the simulation. When I was a student, like you guys, we didn't have the kind of computers what you people have today. I'm talking of 1970s when I was studying, 60s and 70s. But when I became a professional, I started using these computers in 70s and 80s. And I realized that what we used to do in a classical manner, the analysis has become more and more with high fidelity when I use computers. And now with the advent of artificial intelligence, data analysis, data mining, machine learning, and augmented reality, virtual reality, I think a simulation has become already a biggest tool for development. And it has reduced the requirement of experimentation, hardware realization, number of iterations which we used to do earlier with hardware. We had to make one hardware, it doesn't work, then we redesign, we bring another hardware. So that iterative process which was there earlier in bringing out a final product will certainly get reduced in terms of time and cost. And simulation with these new facets will play a major role. And it will become not only in the science technology field, it is there now in the social field, it is there in the political field, it is there, you are seeing everywhere. I can now today do a simulation of the complete political system of the country. I can do a simulation of the environment today. I can do even the weather system simulation. I can do the road transports on the transport system on the road simulation. So I think it has become a major tool for decision making and also getting perspective for how the development should be done. So it's a simulation and modeling is the in thing today with the kind of technology growth that has taken place. And quantum computing will come tomorrow, which will give another dimension to this particular science of simulation. What I do on a supercomputer will be done in no time using the quantum computing technologies. So it will become like on a fingertip. So that's the way it will happen.
Thank you so much, sir. The last question is from Aruna. Do you think government should initiate more schemes for interrelating science, technology, research with society?
Yes, in fact, Science for Society is a major platform today. All the projects, in fact, our Honorable Prime Minister has given a call in the 2015 Science Congress. And his focus of the address was that science for society. That means all the projects which we are talking today in the domain of science and technology, they should be having a character called translational research, and translation should be used for solving the problems of the society. That's why in my slides also I have said all the priorities which I had identified. If you look at them, those priorities are basically for the purpose of meeting the needs of the society, whether it is food, agriculture, transport, security, communication, whatever that. That means it helps the society to develop. So we should have larger number of projects which will directly affect the societal benefits, bring in societal benefits. And I agree with that. For that, already there's a push. If you see the CSIR, your own department today, CSIR has been doing translation now in a much bigger way than what it did about 20-25 years back. Now they're transferring technologies to the industries, involving industries together. And those projects he took up, and he was in a position to bring all the CSIR labs to come together and take projects to solve the problems of this pandemic. I think already that movement is here. I think we should make it on a much larger scale in all walks of life.
Thank you, sir, for so patiently and nicely answering all the queries. We feel really honored to listen to your highly enlightening lecture, sir. And we certainly look forward to listening many more lectures from you in the future. Thank you, sir. I would like to hand over the session to the next segment of the session. Thank you.
Thank you. Thank you.
Thank you very much, sir. Our students have made a small poster which was displayed to summarize a few points in your talk, sir.
Sure, sure.
And the way in which you have blended the basic science for the societal problems and highlighting the importance of modeling simulations, artificial intelligence, data science, Internet of Things, virtual reality was very, very contemporary. And talking about the future aspects in this pandemic is very motivating and fills the students with a positive energy. And I, along with several of my colleagues, Dr. Aayog Dhawan, Dr. VM Tiwari, Dr. Kalai Selvi are there. And before we go, I would like to ask Dr. Tiwari ji, you have some questions to Professor Saraswat?
No, we just wanted to thank and say, sir, it's always inspiring listening you, sir, and we look forward for your blessings, us and CSIR.
Always welcome, anytime.
Thank you. Dr. Dhawan, hello. Thank you very much. And we have Dr. Kalai Selvi, and she will be taking the honors of taking the.
She has been an active director working with NITI with many of the projects. Yes, madam. Anything I can do?
Yeah, thank you, sir. Good evening.
Under your leadership for energy sector, sir.
Yeah.
Dr. Kalai Selvi, please.
Yeah, thank you very much for the opportunity extended by CSIR SRTP to propose vote of thanks in the Eminent Scientist lecture series of today, wherein the visionary leader of self-reliant India, Padma Bhushan, and the Honorable Member of NITI Aayog, Dr. Vijay Saraswat, has delivered an enlightening, mind-blowing, thought-provoking, and extremely informative talk on science and technology for sustainable society. Sir, your indication on triad system that transforms our nation and science, that plays the role of a principal driver to bring in changes which are the milestones of growth and development related to the socio-environment, socio-economic, and environment economic revolutions are well taken by us. ABCD approach, 6R and 7C approaches required to proceed with the traditional lean, green and sustainable manufacturing are mind-blowing clues provided by you through this lecture. list of disruptive technologies mentioned by you, along with the points on youth power and transformation, were thoroughly understood by us as points to ponder. Thank you very much, sir. Thank you very much for such an outstanding lecture. And I, on behalf of CSIR family, thank you so much for the time being spared by you in enlightening us this evening through your lecture. I wish to place on record my sincere thanks and appreciations to CSIR NIS to Johat for ably conducting this SRTP, the first of its kind program under the umbrella of CSIR. Special thanks to fellow directors. Congratulations to Dr. Shastri, Director of NIS to Johat, scholars and scientists, and CSIR family members involved in this SRTP program, and most importantly, the participants who are the real contributors in making this SRTP lecture program a successful model. Thank you one and all. Sir, on my personal grounds and on behalf of CSIR City, my heartfelt thanks to Dr. Vijay Saraswat. In every meeting, we always remember the timely help rendered by you. Thank you so much. Today we are able to say that we are in energy field means it makes a lot of meaning, and the complete credit to you. Thank you very much.
Thank you. Thank you.
Thank you, sir.
Namaskar.
Thank you, sir. Namaskar.
Thank you so much. Thank you.